Hello, everyone. Welcome to ADI Summit. My name is Sumeet Puri, and I'm the Chief Technology and Solutions Officer here at Solace. And for the next 25-30 minutes, I'll be taking you through this exploratory journey called the Kafka Mesh and talking about these technology patterns, certain challenges in modern event-driven applications, especially the ones who are using Kafka for all kinds of use cases. So let's dive right in. If we explore how enterprises have evolved over the past few years, we've seen various trends come about. We've seen application integration go from very point-to-point interactions, message-oriented middleware, then into service-oriented architecture patterns, evolving into APIs and API-driven patterns, and then more recently into an event-driven enterprise. Patterns such as Lambda-based solution building or Kappa have been in use, and we've also seen a big explosion in IoT, where edge and edge to core, edge to cloud communication has exploded. So applications are becoming more and more distributed than they ever were before because of these multi-site deployments. And organizations, whether it's retailers, whether it's logistics organizations, whether it's manufacturing companies, mines running connected mines infrastructure, are connecting thousands to millions of devices. Why is this becoming even possible? Again, there are a lot of drivers. There's the industry adoption, advent of new technology, technologies like Kafka becoming extremely popular, but event-driven architecture has been around for a while. A key reason, at least in my observation, that has caused this popularity to grow for such event-driven or streaming systems is because network for the past 7 to 10 years has become faster than disk and has consistently becoming faster. It is the bandwidth, the latency capability that we have in the network today is much better than what we have in disks. And that's why we are streaming even our movies and our music, we're not carrying them around. So with this ability of the underlying network, when the physics changes, new patterns emerge, and a lot of these enterprises that I've talked about, from retailers to banks, from logistics companies to government agencies, as they are becoming event-driven, with Kafka's popularity, Kafka has been the platform using which many of these enterprises have started their event-driven journey. And we've seen Kafka getting used in all kinds of flavors. So while there is the open source Apache Kafka, which again, probably is the most popular Kafka environment where people are just downloading it, experimenting with it, putting it in production. But then there are a lot of commercial offerings. So Confluent, of course, the creators of Kafka, they have their Kafka-based platform. We have the hyperscalers. So from AWS offering MSK, Event Hubs, again, speaks a Kafka interface. We are also having companies such as Cloudera or TIBCO offering their own messaging and Kafka estates. So enterprises becoming event-driven in a distributed environment and using a lot of Kafka is becoming quite common. This new pattern of being event-driven, this new pattern of distributed systems is throwing up new challenges, as any new evolution, any new innovation would, right? So let's explore these challenges a little bit. So first and foremost, deployments of applications are getting more and more hybrid cloud, more and more multi-cloud. So you have a lot of applications on premises, and probably you use some Kafka for those applications as you modernize, as you re-platform, let's say, a database-driven application to an event-driven application. And similarly, maybe you have some loyalty microservices or some other AI-based systems that you built in the cloud, and you use some Kafka there. Again, could be different flavors, but let's say Apache Kafka. How do you stream data between this on-premise deployment of Kafka and the cloud-based deployment? There are replication technologies such as Mirror Maker in the open source world, and then quite a few others. Confluent has replicators. Brooklyn was created by LinkedIn. But then all of them have their own sets of challenges depending on which one you use and how you use them. Some is partition by partition replication or topic. Some are allowing you to do filtered regex expression, but it's not smooth based on what we've seen in the industry. Then there is the big API first, API adoption paradigm that is happening in the industry, now evolving into becoming event-driven APIs with async API as a standard. So how do we interoperate between the Kafka streaming microservices environments and the API-based front end? So there's integration required there. Often this is done with Kafka proxies, or some API gateways have this ability to talk to Kafka, but API interactions are often always request reply, and Kafka inherently wasn't built for request reply interactions. So there's complexity in getting those interactions right. Furthermore, with IoT becoming more and more popular, and it's only increasing the number of devices that we are going to have to connect to, how do you stream information from the edge to the core or the cloud where Kafka is running? And this would often be over MQTT as a protocol. So there are MQTT brokers, and some MQTT brokers have plugins into Kafka. But again, similar problems that we see with API gateways, where request reply is not inherently supported. Command and control is not inherently supported in Kafka. So how do you bring these two worlds together? For capture and analyze, it's good enough. You can take a lot of these applications and stream into Kafka, but for command and control, and also for distributed environments where you want a factory floor which has lots of machines, assembly lines, and factory operating systems connecting into a cloud-based Kafka install, right? So how do you have that information streamed across sites, right? You need better distributed streaming technologies. Now, we've looked at three patterns, but let's look at the challenges, the technical challenges in all of these patterns, right? So filtering while preserving order is a challenge in building transactional systems. Now, Kafka was built for analytics, for big data kind of systems where order is important, but not always important. So for example, if you're getting a new order followed by an order cancel, your cancel should not come ahead of the new order. And in Kafka, we do this with putting both these events, the order new and the order cancel, into the same partition. But then if you want to filter by country, or you want to filter by order type, and these orders for a given customers are striped across multiple partitions, how are you going to be consuming the orders of this particular customer in sequence? Because these orders for the sequencing of their status, order new and order cancel, were striped to different partitions. So with transactional systems using Kafka, then there are workaround and filtering and KSQL and KStream that you need to do, but it's a challenge, and there are complex ways to solve that challenge. Again, coming to distributed systems, how do you replicate across multiple flavors of Kafka? So in point one, we talked about that, okay, you've got two Kafka clusters and you're going to replicate across the two, but how do you replicate across multiple Kafka clusters with different technology providers, different flavors? They have their own replication mechanisms, and some providers do not focus on replication. And then lastly, while Kafka is being used in some of the newer modern applications, all enterprises have some legacy. And depending on how mature your IT systems are, you can have a lot of legacy, right? You can have MQs out there, you can have ESBs, you can have open source messaging systems such as Rabbit or ActiveMQ. You can have databases. The Kafka world needs to interact with the non-Kafka world. And see, all of these challenges are intersecting with each other. They are interdependent, and they don't exist just on their own, which compounds these challenges. So if we were to examine these challenges and take a stab at how do we solve these challenges, right? We've seen the notion of the mesh architecture penetrate many patterns, and we've applied this, at least in my practice, I've seen what if we had a mechanism where we had a network of event brokers for solving quite a few of these challenges, especially with transactional systems, especially where you need things like request reply, where you need things like filtered topic streaming, where you need to have the notion of IoT connectivity with protocols such as MQTT, APIM connectivity with native support with protocols such as REST, and the ability to translate these REST topics into Kafka topics or even wildcard-based subscriptions in a very distributed, multi-cloud, edge-to-core kind of an environment. So we have a mesh of those event brokers, and Kafka, because Kafka is also an event broker, basically participates in this mesh. So at the edge of the mesh, as you can see, there are multiple flavors of Kafka. So publishing and subscribing, streaming into those Kafka clusters. While for transactional systems, they deal with event brokers who support features like topic routing, event sourcing with replay, but wildcard-based filtering, native request reply, dead message queue handling, the ability to do multi-protocol translation without proxies, so from REST to MQTT, from JMS to AMQP, and all of this with intelligent routing such that an application, a microservice or a serverless application publishing an event or calling a request in a cloud-based environment can easily reach out to Kafka deployed in a private cloud, let's say a Kubernetes deployment on premises, without having to worry about where these applications are deployed. So that's the notion of Kafka Mesh, connecting Kafka clusters with each other across different flavors, connecting non-Kafka applications from microservices to iPaaS, from APIMs to IoT and connected devices in a smart, intelligent, guaranteed, secure mesh. If we look at these patterns a little bit further, right, let's look into the technical detail. So what can you do with a Kafka mesh? Again, you can replicate. You can replicate Kafka to Kafka across various flavors of Kafka. And this replication should be smart. So you may not need to replicate the entire cluster. You should be able to replicate certain topics and certain topics down to very fine-grained hierarchies. This replication, this streaming across Kafka environments has to be guaranteed, has to be lossless, and has to be secure across multiple sites. And with security, this includes encryption, this includes authentication, authorization, all aspects of security, especially in today's internet, and the challenges we have with cybersecurity. Furthermore, you need real-time connectivity between Kafka and non-Kafka environments. And lastly, and very importantly, how do you govern all of these events that are now flowing through this distributed multi-Kafka and Kafka, non-Kafka environments? You need to have an ability to visualize, discover, catalog, and make sense of the Kafka mesh. So a sort of a portal, similar to what we've seen with API portals, to make sense of these Kafka environments. Getting into further details of all of these topics, right? So just graphically representing what we've just seen. So starting point of a Kafka mesh, again, you have multiple flavors of Kafka or multiple open source Kafka clusters where replication is a bit weak, and having these event brokers working in a mesh to stream information from one Kafka cluster to the other. And this is bidirectional streaming. Anybody could be producing, anybody could be consuming, and there's a lot of intelligence in this mesh in the middle, which we'll see as we go, right? So let's explore the ability to filter in sequence, the guaranteed delivery in sequence, filtering, again, without having the challenges of those sequencing within partitions. So let's say you have all of these topics, you have order topics and you have customer topics being produced into this local Kafka cluster. And then you have MSK, where you have a consuming application who's only interested in customer-specific events. They are not interested in orders. Order management is on premises. Customer management or loyalty management is in the cloud. So an application here in the cloud in AWS is looking at only customer events. So this mesh learns based on what subscriptions are being injected by the subscriber, and only those events, only customer events. And you can also see the wildcard here. So only customer events, anything that starts with customer, there's a case problem here, so assume it's all uppercase, where these customer events are going to flow from on-premises to cloud and nothing else. And no configuration is needed as to flow these topics from A to B. The mesh automatically learns these brokers are always talking to each other and sharing their subscriptions. Now, we've seen information flow. Another problem that we've seen in mesh environments, especially when they're done with replication technologies, which are disk-oriented replications, is they are not always WAN optimized. So for example, because they are not topic aware, the fan out at the edge doesn't happen. So let's say we had that same customer information go into an MSK and also a Confluent deployment. The mesh in this case learns and only a single copy of that event goes from on-premises to cloud, and it's fanned out at the edge. So both of these instances, whether it's the MSK or Confluent, and they could even be, depending on scalability, they could even be feeding off the same event broker. Doesn't have to be two event brokers, but for clustering reasons in the same site, we can have a multi-event broker environment as well, right? Encryption, compression, edge fan out is all taken care of through this WAN optimized mechanism of moving information, moving events from on-premises to cloud. Again, guaranteed delivery, extremely important, guaranteed delivery with replays. So Kafka has the ability to do event sourcing. You can do replays in all of these Kafka environments, but you can also do it at the event broker level. So what if you lost this WAN connection for a couple of seconds, right? The event brokers have the ability to do guaranteed delivery. They have the ability to do throttling here, and they also have the ability to do cascaded replay. So you could say that I received all the events, but my application did something funny, and I've lost all of those events. Can you please replay them back to me? So you can go all the way to the source, or you can replay them closer to the deployment of your applications from the local event brokers as well. And putting it all together, so you've got this Kafka mesh operating, which allows these Kafka clusters to be talking to each other. But what about non-Kafka applications, right? How do you get IoT connectivity, MQTT to Kafka, and even non-Kafka microservices interoperability, iPaaS and API platforms or cloud-native platforms directly doing publish-subscribe patterns into an event broker which is close to them? And this is especially true for transactional systems where you need that filtering, you need that request reply, you need that dead message queue handling, and also integrating with the current or legacy technologies where you need standards such as JMS or in modern times even AMQP, which Kafka doesn't support. I mean, it partially supports, but because Kafka doesn't have the notion of queues, it can't really support those standards for those patterns. So the ability for you to talk to these legacy environments, that's where, again, Kafka Mesh becomes super interesting in bridging the old world to the new world. And then the design time, the discovery time, the cataloging time. So as you see all of these applications streaming information, how do you catalog? How do you discover what is happening in your Kafka clusters? So the Kafka Mesh has to have an ability to introspect, to listen to discover these various Kafka environments and also non-Kafka environments. So the way that you can catalog these, visualize this, you can go and look into a particular event, find its topic, find its schemas, see who's publishing it, see who's subscribing that particular event, and draw a graph of dependencies which help you with governance. So even if you have a single Kafka cluster, you are going to need a way as you scale up to catalog it and find out what is going on in the enterprise. So that's basically the capabilities and some detail on defining what the Kafka Mesh is as an idea. So it's a network of event brokers with an event portal and connecting into Kafka environments and non-Kafka environments, streaming all kinds of events. So now let's quickly look at a few use cases. So IoT, I talked about it, again, big data explosion happening there, but also evolving from a pure capture to a command and control paradigm. And IoT applications are inherently event driven. So whether it's connected cars that you see here, and you've got to talk to your vehicle when you press a button on your app to start the air conditioner of your vehicle, that's an event that flows across multiple sites, but it could also be going into a Kafka fronted data lake for machine learning analytics for analyzing user behavior. So for those environments, you could have a connected car, you could have a connected building, there could be a connected factory, a connected mine. For your data analytics, you may be doing, let's say, stream processing with Kafka to feed into whether let's say it's Spark or some sort of K-streams or any other streaming analytics capability. You will have command and control applications. So you may have microservices or serverless applications which need to respond to these requests that are coming in. So when you say start my car or start my air conditioner, the business logic component there is often request reply. It's often, again, needs to be done in order, and your microservices need connectivity. So a traditional event broker which speaks topics, which speaks queues as the node of that Kafka mesh is more useful there. You can have that event broker talking MQTT or APIs at the edge. So some edge filtering, edge processing would also be needed on this factory floor. And then guaranteed backhaul into the Kafka clusters here allow for this end-to-end event streaming. Exploring a related but different use case. So let's come from the factory floor to the warehouse or to the order management systems, inventory management systems. Again, very transactional in nature, and having Kafka deployed sometimes for microservices, but often for analytics. So this is an example of what I've seen at a customer recently, where they have their e-commerce and order management applications built on Kafka. These are microservices based, and the shop front, the e-com front is going into this brand new re-platformed order management system. But then the fulfillment systems also have SAP connectivity behind them. There are warehouses which have MQs deployed into them for, again, historical reasons. And the storefront, the stores are very distributed, and these are often disconnected. They could be in remote locations, and you want to stream events from point of sale systems. You want to stream events into real-time inventory into the stores, and these are all over non-Kafka, sometimes API-oriented, sometimes IoT-oriented protocols. Plus, this particular enterprise has AWS MSK for lots of analytics processing also. So you see Kafka being used for microservices, you see Kafka being used for analytics, and then your fulfillment system is also very microservices based. Some iPaaS being used, some function serverless applications are being used here, and SAP connectivity where they have an embedded event mesh also is there, right? So that's a classic example of a Kafka mesh integrating Kafka clusters and Kafka and non-Kafka applications. Moving on to banking and payments. So payment processing systems are evolving in a dramatic way now. Lots of drivers for this. Some drivers are changes in payment standards, SWIFT standards, where we've seen ISO 20 or 22 becoming popular now. SWIFT has a new AMH capability, which is driving some of these changes. A lot of these payment systems are becoming more digital, more real-time, more cloud-native. And as a result, there is re-platforming happening all the time. But as these systems are getting re-platformed, you always have a lot of MQ on premises, right? How do you stream from this MQ into Kafka-based environments? Again, we've talked about this in the patterns before, but connecting your mainframe or your MQs, even based on open systems where you want to source your payments or you want to settle your payments into, let's say, Kafka for analytics environments. And with all the encryption, filtering, WAN optimization requirements that we've talked about, so Kafka Mesh as a pattern becomes very useful in bridging the traditional world with the modern world, whether it's for microservices or analytics. And we are seeing a lot of this happening. Concluding thoughts. So we've seen a few patterns. We've talked about the Kafka Mesh as a pattern. We've explored a couple of use cases from IoT to inventory and order management to banking. We could go on and on with use cases. We talk about airlines and logistics. We could be talking about even government scenarios or smart city scenarios where we are seeing the Kafka Mesh and the event brokers powering it, working together. So I work for Solace, so let me give you a little perspective of Solace there as well. So Solace is one of those event brokers which you could use as the core in the Kafka Mesh. There could be others, so pick your best, pick your favorite technology there. Similarly, there are multiple Kafka distributions. Pick your favorite Kafka distributions. But if you look at your use cases, where do you need Kafka or log style event brokers? And where do you need mesh style event brokers such as Solace in the middle? Typically, many enterprises need both. Why do they need both? Because most enterprises have both patterns. Enterprises have the analytics and streaming patterns for log aggregation, stream processing, personalization, fraud detection, feeding into data lakes or with AI/ML data streams. And also getting into data mesh now, where data as a product is being made available. And similarly, enterprises also have a lot of transactional systems. So whether it's event-driven microservices, request reply flows, hybrid multi-cloud distributed environments, IoT interconnects, and Kafka versus the Solace style architecture, both are suited respectively to analytics and transaction streaming requirements. And also data mesh, data as a product becoming popular needs both, right? So it depends on where your data is being exposed as a product. And also, how are you going to catalog that data as a product? How are new applications going to find out that this real-time data as a product, which is available as a stream, whether directly off an event broker, a mesh style event broker like Solace, or a Kafka style event broker, you're going to need the catalog and the discovery capability to list that data as a product, data as an event stream. So that's basically what a Kafka mesh is. A mesh at the core, Kafka at the edges with governance and cataloging all around it. And we are seeing these patterns emerge. I'll be very glad to hear your points of view, and please type in the comments, reach out to me, and thank you very much. Thanks for your time. Enjoy the rest of VDA Summit.